Okay, you're welcome. So, well, let me do a quick recap then. So there were some of you all that were mentioning that you weren't here earlier. So here's what I'm going to do. I'm going to go ahead and tell you what you missed out on today. And this is like a basic review for everyone. And then we're going to get into those questions. So here is the thing. When it comes to bond types, there are three major types, but then there's a subcategory under covalent, okay? Now, you all know all this week we've been talking about writing chemical formulas. We spent 3 days on writing chemical formulas, right? Well, when you get to ionic compounds, what you have to know is that it's between a metal and a nonmetal, yes. But in terms of their electron movement, they are transferable. They are transferring to each other, okay? Ionic bonds transfer electrons. Now, when you look, though, at covalent bonds, they're actually sharing. So think about the word co, meaning two. They're sharing. That's between two nonmetal elements. But there's also a subcategory under covalent bonds. And for covalent bonds, this means that you're going to have either a polar covalent bond. And remember, covalent bonds are between two nonmetals. So if you have a polar covalent bond, that means it's usually hydrogen plus some other nonmetal element, okay? So you're talking about things like hydrogen chloride, hydrogen sulfide, okay? Hydrogen fluoride. Usually it's hydrogen and some other nonmetal, but you could also have something like carbon dioxide, okay? Because they're both nonmetals, but carbon has a positive charge, oxygen has a negative charge, and that's why we call them polar covalent bonds. Now, the other subcategory of covalent bonds are nonpolar covalent bonds. So when we say nonpolar covalent, we're talking about usually diatomic molecules. That means those elements that are attached to themselves, like hydrogen attached to itself. So as an example, hydrogen attached to another hydrogen bond, fluoride, iodine, nitrogen. They form the number 7 on the periodic table. So therefore, they're classified as nonpolar covalent bonds. And then the last category are your metallic bonds. Now that one is easy. It's just metal plus metal. All right. So if I get like sodium mixed with magnesium, okay, that's just a metallic bond. And with the electron movement, they are generally delocalized. That means it's just an abundant supply of electrons running rampant, okay, running rampant. So let me see. What was your question? Can polyatomic ions be ionic and covalent? Oh, that is an excellent question. I'm glad you brought that up because I didn't even discuss that earlier, but here's a point of reference. Let's say that you have a polyatomic ion. Oh, well, let me give you this. Sodium sulfate, for instance. Generally speaking, if I ask you to identify, what type of bond this is, well, part of it, good question, part of it is ionic, and the other part is covalent. And I know that sounds crazy, but you can have a dual type process in this particular instance here, okay? When half of the reaction half of the compound, is ionic, and then the other half is covalent. Now, it's almost like you want to say majority rules, but what's going to happen here is you have sodium that is a metal combined with other nonmetal elements. So that's why it's kind of like a dual process. Yes, very good question. Very good question. Now, I also mentioned today, as a reminder, that those things that you see in red, those, of course, are your cations. They're positively charged, okay? And because they're positively charged, that just simply means they have the ability to give up their electrons. Whereas those things that are in green, including hydrogen, which should have been over here above group 17, they have the ability to combine with cations to form the ionic bonds. So basically, anything that's in red and green can combine together to form an ionic bond. But if you have any element that's in green combined with any other element that's in green, then those are covalent bonds, okay? So now, Here is the thing. I drew the number 7 on the periodic table and I included hydrogen because hydrogen, along with the number 7 of elements, those are nonpolar covalent bonds. They are generally attached to themselves. Now, why do I bring that up? Because right here again, when you look at ionic bonds, metal plus nonmetal, metals lose electrons. Cations, like don't correct me. I'm from the South. And we say things different like you do up north and like you do on the West Coast, okay? And on the East Coast. So if I want to say pecan and you say pecan, we are both right. So metals lose electrons. Nonmetals gain electrons. Now, because they are opposites of each other, that's what you have to remember, okay? That's what you have to remember. If there are opposites, that's an ionic bond. Think about the word ions. Look at the prefix in that word, ion. That means ionic charge, okay? That means ionic charge. So as an example, left and right, up and down, apple and orange, boy, girl, man, woman, okay? Opposites. However, what you have to remember too, and the reason why I'm bringing that up is because this is another key factor. Ionic bonds have high melting points. They are generally crystalline solids, like salt. If you've ever looked at salt under a microscope, they just look like little crystals. Sugar, it looks like little crystals, but sugar is not an ionic bond. It's not going to conduct electricity. That's a side note. Because of the formula for sugar is sucrose, and it has carbon, hydrogen, and oxygen. So that's a completely different story. But also, ionic bonds conduct electricity in water, okay? Yes, they conduct electricity in water. Now, covalent bonds, let me go back over here. Ionic bonds, they have the transfer game. Like I said before, they're transferring and receiving. I give you one, you give me two. Metals, which is what I'm doing now, I'm giving away, okay? I'm generally giving away my positive cations, okay? I'm giving away positivity. However, the negative person that was on here earlier, they always want to receive attention, okay? They're always wanting to receive attention. So therefore, yes, only in water. Yep, only in water. Now, when it comes to covalent bonds, sharing is caring. I mentioned this earlier, like the Care Bears say, sharing is caring. So when you have covalent bonds are basically saying, hey, it's only happening between nonmetals, okay? Between nonmetals, and when you have sharing is caring, that means that they're both going to get the same thing because they're both alike, okay? So when you have nonmetal, that just simply means they're going to share electrons in order to reach their full outer shell. Now, when we get into that later on, you'll understand what that means and what that represents. Now, there are bond types with covalent bonds, such as single bonds, double bonds, and triple bonds. Now, as a tip to help you remember this, polar covalent has an unequal sharing of those electrons. So here's an example right here. Okay, I talked about this one earlier. Water is an example of polar covalent compounds or a polar covalent bond. Why? Because water has 2 atoms, oxygen has 1. So that's unequal sharing, like your stingy friend. They always want to get a ride from you, but when you ask them, they don't want to do it. So unequal sharing, even though y'all are opposites, one is positive, one is negative, okay? There's an unequal sharing in that relationship. However, nonpolar means I'm going to share equally. Why? Because we are stuck together. So here's an example of what I mean by sharing equally. Remember how I said there are 7 elements that share equally? Right here. Nonpolar. We're stuck together. Hydrogen is attached to hydrogen. They're like Siamese twins, stuck together. Nitrogen attached to nitrogen. Okay? Okay, now, Remember, polar covalent bonds do not swap charges, okay? Even though you're looking at the fact that hydrogen is a positive element and oxygen is negative, they're still both nonmetal and they're not swapping charges. You're basically only looking at the fact of what it can do, okay? Polar means opposites, North Pole, South Pole, positive, negative. Both of them, though, are nonmetals, okay? They're both nonmetals. Now, metallic bonds, as I mentioned to you all before, metallic bonds, that's an electron party because look, metals release electrons in a shared pool. That means you just have electrons just all up in there, okay, just moving freely. They make metals conductive, meaning they conduct electricity. They're malleable and they're shiny, all right? It's a sea of electrons. So to recap that whole process, okay, as an example, just remember this part right here, okay? Let me zoom in so you can see that right there. Ionic, metal, nonmetal. Covalent, nonmetal, nonmetal. Metallic, metal, metal. Ionics transfer electrons, covalents share them. And metallic means we all over the place because it's just a lot of us. Yes, metallics are delocalized. Yes, and delocalized means I can move about. I'm not stationed to just one area. D meaning to remove. I can actually just go wherever I want to go as a metal, as a metallic bond. Melting point. Ionics and metallics both have a high melting point. Covalent is low to mid. In terms of conductivity, ionic bonds only conduct electricity in water, but metallic bonds can conduct electricity anytime, any place. Covalents are very poor at conducting electricity. So like, that's just like saying, let's say, can nitrogen conduct electricity by itself? No. But if you say sodium chloride, absolutely. Because of dissociation. The question is, why do they only conduct electricity in water? Whenever you guys get into all these solubility questions, hence the word solubility, dissociation means that the ions are able to have a better response in an aqueous solution. So whenever you all see how chemical reactions are written and you see the word AQ like this, if I say sodium chloride, okay, solid, and then it combines with water, you'll end up with sodium hydroxide and hydrochloric acid. So what tends to happen is sodium ions and chlorine ions dissociate, like they break up in water because of them being ionic. And ionic just simply means, hey, if you break apart, one of you is a metal, the other one is a nonmetal, they're able to conduct electricity because of that process, because one is metal and the other one is nonmetal. And because they form an ionic bond, that tells me that the energy there is higher. Think about, why would you take Gatorade, which, I mean, I wouldn't recommend Gatorade, but that's just as an example. If after you worked out, you tend to pick, let's say, Gatorade because of the salt content that you need to replenish. We sweat salt from our bodies. In order to get electrons to get triggered in your brain to fire off those neurons, you need group 1 elements, which are your metals. But if you go and get, let's say, sugar, you're not doing anything but jacking up your system. Sugar would be classified as like a covalent bond. That's why it doesn't conduct electricity within your body. It does the exact opposite. I'm going to go through some questions with you. Now, we did some of these earlier today, right? But I have some new ones that's going to review everything that we talked about this week, from what I just discussed all the way to writing out chemical formulas. So now it is test time, okay? You can put your answer in the comment box. I'm going to start off with the T7 versions of these questions. And for those of you all that are familiar with the TEAS exam, this deals with recalling and recognition. The T7 exam is what most nursing students have to use in order to get into the nursing program. HESI A2 style questions, they deal with reasoning and application. But something else you all want to know, they're a little bit more challenging. Not too much more, but they're a little above the HESI exam. Yes, you know what, Shaz, I find a lot of students say the same thing. It just depends on who you're talking to. Okay, so I'm going to start first over here. Hey, Anna, how you doing? I'm going to start first with the T7 exam questions, and then we're going to, parallel back and forth, okay? So the first question, we'll do like 3 or 4 at a time, and then we'll switch it off. All right, y'all ready? Let's go. What type of bond forms between a metal and non-metal? Now, we just talked about this, so y'all better get this one right. Exactly, ionic. Okay, number 2. What is the formula for magnesium chloride? What is the formula for magnesium chloride? Okay, I'll give you this hint. I'll give you a little hint. Magnesium has a +2 charge. Chloride has a -1 charge. Do your thing with swapping. Hint, hint. B is correct. B is correct. Number 3. Which compound is a covalent compound? Which compound is a covalent compound? Think about what we're asking, okay? Think about what am I asking you? If you know what these elements are, then you should know how to answer this question. Hopefully you have a periodic table on standby. All right, good job, y'all. C. Brianna. Yes. What is your major? Are you going into the nursing program? What is your major? And yes, you got to learn all of this. Yes. Houseway. Yep. You got to know it all. Okay. Now we're going to turn over here to this side. Okay. So nurse Brianna, let's get to it. Let's get to it. Number 1 on this side. Why does sodium form an ionic bond with chlorine? So why do they form bonds? Okay, I see a lot of answers. Yep, because sodium donates an electron to chlorine. And yes, metal and non-metal. Good job, Maria, for stating that. For those that forgot, metal and non-metal is ionic bonds. Number 2, why does magnesium form magnesium or MgCl2 instead of MgCl? Because some of you all may have chosen A from the last time, but look, they're asking you why. And I kind of gave you the hint when I switched the screen over. Exactly, Brianna. Non-metals givers. Oh, no. Non-metals are receivers. Metals are givers. Exactly. Letter A is correct. Letter A is correct. Okay. Number 3. Why is carbon dioxide covalent? Why is carbon dioxide covalent? And think about the answer choices. Yup. If you all said C, you are correct. Okay. That's right. They're both nonmetals. Exactly. Okay, the next question. Now you all have to write the formulas out. So what I'm going to do, and let me get rid of these little red marks. You know, when you write formulas and stuff, the computer doesn't recognize it. Okay. So again, these are like your HESI style questions versus your TEAS questions. So I want you all to put your answers in the chat box for number 4. What is the name of Na2SO4? Okay, you need help with these, okay? I see 2 different answers. I see B and I see C. If you said C, no, no, no. Numerical prefixes are only for those elements that are nonmetal, nonmetal. Nonmetal, nonmetal covalent compounds are the only ones that get that numerical prefix in the name. This left side is T7, the right side is HESI. Number 4. We're still on number 4. Hey, Trini. How y'all skipping to number 5? We ain't done with number 4. Number 4 is sodium sulfate. Remember what I said yesterday for several of you all that were here. If you see 3 different elements, that tells you ITE or ATE. No, Sophie, I'm messing with y'all. I'm messing. Yes, y'all got excited. Yes, galactic goddess, that is correct. You only use numerical prefixes when it is a covalent compound. That is correct. If you say sodium sulfide, the formula for sodium sulfide is Na2S. And that's not what we're looking at. Na2SO4 is for the sulfate ion, is that part. Number 5. What is the formula for aluminum oxide? And notice, I didn't say aluminum trioxide. I said aluminum oxide. No, N2 is nitrogen. If you had a formula, if you had N2O, that would be dinitrogen monoxide because both of them are nonmetals. Okay. Number 5, aluminum oxide. Aluminum, again, I'm going to assume that you all don't have a periodic table. Aluminum has a +3 charge. Oxygen has a -2 charge. So all y'all putting C incorrect. Y'all look at those. Look. Aluminum has a +3 charge. Oxygen has a -2 charge. When they swap, aluminum picks up the 2. Oxygen picks up the 3. Brianna, you're taking classes now, right? Are you in chemistry now? I know you mentioned you have biology and chemistry and math, I think. Yes, Atlanta, Russian, Manny, and Petty. Yes, you love chemistry. I do too. Number 6. Okay, well, honey, you learning right along with what we're doing now. Then, by you being in here, it's being a part of your psyche. It's being a part of your mind. You're welcome, Trini or Trini. The question is, which compound requires Roman numerals? Now, we talked about this too earlier this week. Yes, galactic goddess, transition metal. So yes, sulfide, yes, Atlanta, Russian, Manny, Petty, y'all are correct. It is C. And why? Let me zoom in so y'all can see why. Thank you. I ain't even got to say nothing. So let me pin Safa's response. Let me see. Here we go. Pin this comment. There we go. Y'all see what Safa wrote, right? Iron, copper, tin. Okay? Those elements are the ones that have more than one charge, and they are typically your transition metals. So with that being said, let's go to this side now. This is how the HESI would ask you those questions. Why does sulfate keep its identity in sodium sulfate? Why do you wish you had to take the HESI? Why? The answer is A. For those of you all that put A, that is correct. Because sulfate, that's a sulfate ion. Number 5, why is the ratio 2 to 3 in aluminum oxide? Well, the HESI exam it's supposed to be like a step up from the TEAS exam. Oh, okay, okay. The answer is A. Charges must balance. Remember, it can't be because they share electrons. No. Usually in ionic compounds, one is given, the other one is receiving. But in this particular case, they must balance out. That's what I was talking about earlier, how some teachers teach writing out the chemical formulas. They make it hard rather than just saying swap the charges. They want to go through all of this about balancing the charges, and they do this long way. And I'm like, ain't nobody got time to be doing all of that. Just say swap charges and keep it moving. Okay, Brianna, I'll see you later. Number 6, why is iron Cl3 named iron 3 chloride? Yes, Galactic Goddess, yes. Swapping works consistently, yes. It's very straightforward. This is the answer right here. So those of y'all that put A for number 6, you are correct. This compound here is not covalent. So that's wrong. It's not covalent. Chlorine does not have multiple charges. It only has one. Iron is not a nonmetal element. It is a metal. So this is how you guys are able to do process of elimination. Okay. Yes, that is correct. The charge of iron and other transition metals is based on what they're paired with. Right. So, but let me be more specific. There are some of these have more than one charge. And I talked about this earlier this week where I showed you, I may have taken it off by now. I don't know. I don't think I still have it up here, but I was pretty much showing how some of them have the same type of charge. Like, for instance, iron, hold on, let me see. Okay, like iron has a +2 or +3 charge. Copper has a +1 or +2 charge. Tin has a +2 and +4, so does lead. So there are several elements that have more than one charge that are transition metals. But there are two that are outside of that has more than one charge, which is lead and tin. They're metals, but they're not transition metals. Yes, Galactic Goddess, this is on my website. It's not downloadable. This is actually 11 by 17. This size here, it's pretty big. It's 11 by 17. And it's pretty sturdy material. You know, you can't tear it. unless you cut it with scissors. But this is 11 by 17. And it's like a cheat sheet that I give my students to help them on their test and homework, because it has like the valence electrons. I actually created this myself. It has stoichiometry stuff on there. It has, of course, the mass in grams, the significant digit rules, how to calculate density, a lot of little different hacks. Hey, Heidi, explain the definition of covalent. Okay. When did you come? Yeah, okay, yeah, that's it, Nia. She just said it. Yes, thank you. Thank you, Galactic Goddess. When you talk about covalent, yes, it's what Nia said, okay? Equal sharing of electrons. So the thing is, oxygen, because it's attached to itself, oxygen is going to be a nonpolar covalent bond. And we actually covered this heavily. Oh, no, you're good, Nia. Listen, the more that you all can interact with each other, the better. Sometimes I don't see y'all's questions until after the fact. Yes, 2 nonmetals. Very good, Galactic Goddess. That's right. What is the name? What is the name of NH4NO3? Now remember, what did I tell you earlier? If you see 3 or more elements combined, you're going to have an ATE or ITE ending. Hint, hint. What type of bond forms between hydrogen and water? Good job. Those of you all that are saying C, excellent, excellent. Now, over here, those same questions that I can ask you looks like this. So earlier we talked about oxygen being a nonpolar bond, right? Well, now, why is oxygen a nonpolar bond? Let's do process of elimination. You know, it is not a metal atom. So we can at least get rid of that. Transfers electrons. And again, some of you all came in asking the same questions earlier, and I'm going to give you a quick snippet real quick again so you can see this. Ionic bonds transfer. Covalents are shared. Metallic are delocalized. Hint, hint, hint. Okay, so back over here. Right, it doesn't transfer. Yup, Nia. Mm-hmm. So, but okay. Okay, I hear dipole. Okay, yep. Even though we haven't had that conversation, that's still something key. Okay. So if it's nonpolar, what does that mean? And we did not talk about electronegativity, but it doesn't have anything to do with electronegativity in this instance here either. Okay. So yes, the answer is it has identical atoms. I mean, that just look at that keyword right there. Identical atoms. Okay. Now, and then this next question right here. Why is NH4 plus considered a polyatomic ion? Let's talk about what it's not. It contains one atom. Absolutely not. Poly means 2 or more. So we know it's not that. It's not metallic. Nitrogen is nonmetal and so is hydrogen. It shares electrons equally. Nope. It carries a charge and acts as a unit. That is the answer. Polyatomic ions, you treat them as a single entity. So that means, here's an example of what it means. If I tell you that you have to write a formula for, let's say magnesium let me give you different. Aluminum sulfate. Yeah, aluminum sulfate. Aluminum has a +3 charge. Sulfate has a -2. I always say put it in parentheses, so in case it picks up a charge greater than 1, it goes on the outside. So when you write the formula, you get Al2SO4 in parentheses, and then that 3 is on the outside. But the point in me bringing this up in terms of what I wrote is because when you look at the question and it says, why is NH4 considered a polyatomic ion? And the answer was, it carries a charge and acts as a unit. Polyatomic ions act as one. It's like they're Siamese twins stuck together, and you treat them as one entity, one unit. The last question right here. Why is the OH bond polar? Why is it a polar bond? You know hydrogen is not a metal. You know oxygen does not lose electrons because they're actually receiving electrons. And although we did not talk about this before, but yes, oxygen has a higher electronegativity. And I'll delve a little deeper into electronegativity later on, okay? Yes, it has a higher electronegativity value. And here's a little hint, even right here on my chart that I was telling you all about before. Right in there. Yep. And fluorine is the most electronegative element. Yes. Okay. What is the formula for calcium nitrate? Now, again, I know that some of you all may not have a periodic table on standby, so I'm just going to go ahead and write out this part. What is the correct formula for this? No, I don't do organic chemistry. No. But I do have a pinned post of some accounts that do. Letter B is correct because they did their little switcheroo. Okay. This question, why are parentheses used? What's the purpose in using parentheses? For decoration? To show multiple polyatomic ions? Because nitrate is covalent only? Or to show electron sharing? Exactly. Letter A. Letter A. Hey, Nayeli, how are you this evening? Okay. We got time for, let me see. I got a whole bunch of other, we'll stop at 14. Or maybe 15. We'll stop at 15. So I'm giving y'all, let me see, 10 more quick questions. And this is going to go rapidly, okay? So here's what I want you all to do. I want you all to answer the questions in the chat box, and, well, at least for this side anyway, you're going to put 11 and then whatever answer you get, 12 and whatever answer, 13 and 14, and then we're going to check our answers. I'm good. Happy Thursday to you as well. So let's go real quick. You've got matter of fact, y'all, when you take the TEAS exam, you literally have less than a minute per question. Literally. It's like either you know it or you don't. So the low-hanging fruit questions, you ought to be able to fly right through them. Highlight answers. And if you get it wrong, let me know and we'll go through them. Oh, I can see number 14. Let me see. Okay. All right. Okay. Let's go through these really quickly before my General Chem 2 students come in. We're going to go over the answers as to why they are what they are. Number 11, phosphorus trichloride. This is a covalent bond. Phosphorus is nonmetal, chlorine is nonmetal, therefore you use numerical prefixes in the name. Number 12, iron has a +2 charge, oxygen has a -2 charge. The 2's cancel out, therefore you're left with letter A. Okay, good, Lisa Layla. Thank you. Good job. Number 13, nonpolar overall means they are the same type of element attached to itself, or they're both nonmetal. Hydrogen has a positive, even though it is a nonmetal element, hydrogen itself is positive, oxygen is negative. Nitrogen is negative, the hydrogen that's attached to it is positive. Carbon dioxide. Carbon is in the group that has a positive charge. Oxygen is negative. Sulfur is negative. Oxygen is negative. Negative, nonpolar. And finally, copper 1 oxide. The way you know that this is copper 1 is because copper 1 has a 1, but it switches. It takes the 2. Oxygen takes the 1. The 1 is understood. Okay, got it. All right, good. You're welcome. Okay, on this side now. Why are prefixes used in phosphorus trichloride? Oh, I got to give y'all time to answer this question. Okay, good. I'm glad this is helping you more. Thank y'all. Y'all are so kind. I appreciate you all. I'm glad these lives are helping you all because I know that some of you guys are very intimidated about asking questions with your teachers, because y'all mentioned how some of them have attitudes and they're intimidating to ask questions from. So y'all come on here and get your chemistry life together. Okay. The reason why prefixes are used in phosphorus trichloride is because it is covalent between nonmetals. Why does iron need Roman numerals? Because it can form multiple ions. Why is carbon dioxide nonpolar despite polar bonds? Now, look at this. Y'all get ready to put me into that. Look at this. That little TikTok thing. Look at this. It does not contain hydrogen, so we can get rid of that. Also, it is not ionic because they just told you. Why is it nonpolar covalent? It can't be because it's ionic. Like we just talked about that. And now I know we have not talked about this yet, but it's actually linear. We'll delve a little deeper on that one later on because we technically have not talked about that. But I'll talk about it, later on when we get into drawing out these bonds. Yeah, when we get into drawing out these compounds, it deals with molecular geometry or VSEPR. Yeah, so if y'all look up VSEPR, that's what we're going to get into next week. And then these last, we child. Yes. And we're going to do these last two right here. Okay, these last two. Why is the oxidation state +1 in copper 2O? We didn't talk about oxidation state. So again, that's one that I'll have to come back on because we're going to have to table this one. But let's answer this last question right here. Why are prefixes used in dinitrogen pentaoxide? So we're on this one right here. Yep, because it is covalent.